Hello, everybody. This week we are continuing looking at slope, and we're specifically looking at the equation of a line in slope-intercept form. So slope-intercept form should look somewhat familiar to you because in last week's activity, we were writing equations in slope-intercept form. So we have this form y is equal to mx plus b. M always represents the slope and b represents the y-intercept, which last week we referred to as the starting value or the initial value. It's where it crosses the y-axis. And we're going to look at this slope-intercept form this week. There are many ways to write equations, but this is the most common form that we will use. We'll talk about other forms later on in the year. So just recapping from last week, when an equation is graphed, a straight line is graphed, you can take a look at its slope, it's shown here as m, and its y-intercept of b. So again, we have that equation, y is equal to mx plus b, where m represents slope, b represents the y-intercept, or in other words, the y value, and x is equal to 0. And we're going to look at a few different examples this week. So first of all, this is an example where we have a line graphed already. And again, you looked at this last week already. So we're going to recap here how we would get the equation of a line from this information. So here's our line graphed. What is the slope of this line? Well, last week we looked at drawing slope triangles. And when you have it graphed, that's probably the easiest thing to do. So I'm seeing a triangle here. The best thing to do if you're stuck on this is you want to think about points that are on whole numbers. And sometimes that means it's easier to start with the y-axis, that starting value. And this is part the way through, so I don't want to pick that. This seems to be logical. So using this slope triangle, we're looking at the vertical distance, which here we can see is 3, horizontal distance of 2. That makes my slope 3 over 2. And I can leave this as 3 over 2. I could also say 1.5 or 1.5, but it's completely acceptable to leave the slope as a ratio. So 3 over 2 is just fine. The y-intercept I can see is 1, 2, 3, 4, positive 4. And with those two pieces of information, I can write the equation of my line. Y is equal to 3 over 2x plus 4. Again, it would not be incorrect to say 1.5x. We just typically write the ratio as a fraction because it is a ratio. And it's also easy to see it that way. So 3 over 2. You could have used a different triangle. We could have also done the same triangle here, for example. Like I said, we'll get a little bit more comfortable with doing slope triangles and finding the slope from that. We can also see it's a positive line. So always check that. This is a positive line. My slope is positive. That matches up. So in this example, I'm given the information, and now I need to graph it. Okay, so I have a slope of 3 and a y-intercept of 1. When you're given the y-intercept, I think it's always easier to start with that point. So I'm marking that. And from there, I want a slope of 3. That means I'm going to start vertical, right? So because it's positive, I'm going to go up 3 over 1. If you can visualize a positive line, I don't think you have to worry about whether you're going up or down. So I know it's a positive line. It's going to look like this. So up 3 over 1. So I can think of that slope of 3 as being 3 over 1. 3 over 1. So it's still a ratio. That's what I mean. It's easier to think of it that way. Up 3 over 1. And I can continue this if I wanted to, and I can go down 3 over 1 to follow that pattern. And there you go. That's all the information that I need to graph my line. Obviously, you should use a ruler here. Mine might be slightly off. Trying to go through those points as best as I can. But there's my line graphed. I just need those two pieces of information, and I can put that together, and I can say the equation of the line is y is equal to 3x plus 1. So if I'm given the equation y equals 3x plus 1, I wasn't given it separate, I would be able to pick out of that, oh, the slope is 3, the y-intercept is 1. Final example we're going to look at is where we're just given 2 points. The line goes through the points 3, 2, and 0, 1. And we're asked to find the equation of the line and graph it. Well, there's a couple of things you can do here. You can actually graph these 2 points, and I would definitely say that's completely fine to do, but I actually want to find the distance here, the slope here, the vertical distance and the horizontal distance, and I can do that. We have a formal equation for doing this, and if you were in 8th grade last year, You'll be very familiar with this. If you're not, do not worry, do not overthink this formula here. I'm going to express this with sub numbers here. This just means my first set of coordinates, and there's a number 2 here to represent my second set of coordinates. I want to find the vertical distance, and I find that by finding the difference between my y coordinates. So I'm going to do 2 subtract 1. So I'm starting here, 2 subtract 1. That's going to give me my vertical distance. I'm starting with the y coordinates, over 3 subtract 0. So that's my vertical change, delta y. Maybe I should have put that in first, over delta x. I end up with 2 over, sorry, not 2, sorry. I knew I was going to say the wrong thing then. I end up with 1 over 3. So my slope is 1/3. And I can, obviously I've got the points here and I've got a graph, so I can actually go ahead and do that and I'll be able to see it. 3, 2 would be about here. 0, 1 would be here. I can see that's a rise of 1 and a run of 3. So I could have done it that way. I was just trying to calculate it. So I can also then see where it crosses the y-axis. So we're going to spend quite a bit of time on linear equations, and we're going to find that there are different ways to do everything that we've done today. There's lots of ways to write the equation to get the information that you need. Graphing is good. Calculating that is good as well. So we end up with 1/3 x. And we were actually given the y-intercept here. The y-intercept is 0, 1, as we can see. So we actually have that information already, but we could just have it confirmed in the graph. So my equation here, oops, y is equal to 1/3 x plus 1. And I may as well finish off graphing this. And there we go.